My name is Anne, and today I'll be presenting about continuous integration, delivery, and deployment. So what is continuous integration? It's basically a practice that requires developers to integrate code into a shared repository like GitHub several times a day. So why do you do this? Let me flip the question. If you don't do it, what happens? So consider a scenario where there's a team of developers working together. Developer takes a copy of the current code base and changes it. And as you work with a large team, many developers would be submitting code to the source code repository, and this code would stop to reflect the repository code. So not only can existing code base change, but new code can be added in, as well as new libraries and other resources that create dependencies and potential conflicts. So with code constantly being changed, this can lead to a tendency of infrequent commits, late testing because if you're working on a large project, you're usually on a time crunch, and you have to think about what you want to prioritize on. So kind of like what we're doing, we kind of just want to get everything done, and we're focusing on getting the meat of the project done, then writing the tests. And with that, you lead to more bugs. So the longer a branch of code remains checked out, the greater the risk of multiple integration conflicts and increase of bugs when the developer branch is reintegrated into the main line. So eventually, the repository becomes so different from the main source that you enter merge hell or integration hell, where the time it takes to integrate exceeds the time it takes to make those original changes. So with continuous integration, you follow a series of practices that will help you avoid these bugs. First, you want to maintain a single source repository, so GitHub. You want to automate the build and make your build self-testing by writing your own tests. Every commit should be built onto the integration machine. And once the build passes, you want to test it in a staging environment or a clone of the production environment. And then you want to make it easy for everyone to get the latest version. And then once you have that, you can automate deployment. So following these practices limits the chance for catastrophic merge issues and any work lost due to broken code base. So this is kind of the workflow. You as a developer, you make your changes and you check it in, commit it to GitHub. And then the continuous integration server will automatically detect the changes being pushed to GitHub. And it's going to run its own mini build process where it runs your tests and see if it fails or succeed. And if it doesn't, whether you succeed or not, it's going to send you a notification. I'm sure you've seen this little green button on GitHub before, on some libraries perhaps. So what does it mean? Like, what is a successful build? So the build compiles and makes sure that everything runs on target platforms. And once it compiles, it runs your unit and integration tests and makes sure that all the tests are passing for a green build. Some CI services ensures that the database and code is also in sync, and ensures that by inspecting the code, ensures that there's a healthy code base and it identifies problems early on. So once the build is passing, it labels the build, and then it produces a clean environment to release at any time onto the staging environment or your production environment after a successful build. This is an example of a build failing. So the CI server is alerting the team via GitHub. And with this alert notification, the team can fix the issue at the earliest opportunity. This is another example of getting a notification via Slack. As you can see, there are different builds that are running at the same time, and you can get a notification for a successful build or a failing build. And in practice, this means more transparency, faster feedback cycles, and a guarantee that every branch merged into master has a passing test suite. So integration can be a huge help in keeping a master branch green, which can greatly reduce deploy times, since engineers aren't waiting on build failures to be resolved in master. So there are costs and benefits to practicing continuous integration. One of the costs is that it does take an initial time investment to integrate this practice into your workflow, since you have to build an automated test suite, and that requires a considerable amount of work if you're working on a small team. It also depends on the quality of tests or flaky tests, since your tests might have timing issues, or there's some logical errors in the quality of the tests, and sometimes it's just hard to write tests the larger your application gets. While there are these costs, there are huge benefits to integrating continuous integration into your workflow. You can greatly reduce risk, costs, and time for rework if there are bugs that are detected. So it doesn't necessarily get rid of bugs, but it makes sure that the bugs are dramatically easier to find and remove once you track those changes down. And this encourages frequent automated testing and releases. So the next step, naturally after continuous integration, is continuous delivery or continuous deployment. These are very similar terms since they have the same initials, but the main difference is that once your tests are passing and it's accepted into the integration server, the difference is that the code is ready to be deployed, but in continuous delivery, you do it with a push of a button. So you're the one deciding when to push it to deployment. Whereas continuous deployment, you don't have to you don't have to click enter or anything. It just goes into deployment right away. These are some examples of companies practicing continuous integration. As you can see, Google, for example, they have 250,000 engineers and they make 45,000 commits a day. Like, how do they release fast and build effectively? Instagram and Etsy, for example, deploy 50 times a day, and Facebook releases twice a day for bugs and internal code, but they deploy into production code weekly using continuous integration and delivery or deployment practices. These are some services that help you practice continuous integration. T-Sign is on Travis CI, Jenkins, ColdShip, and Circle CI. And I'll do a little demo of how continuous integration works with Travis CI right now. So I created an account at Travis CI. It's free. If you have a GitHub, it just hooks on. This is a sample project that shows that it's failing right now. This is the project that I created. Just a simple add function. This is a test spec, and I'm using Mocha in my package JSON here. And to use Travis CI, you have to create a .travis.yml or YAML file that detects what language you're using. So we're using JavaScript in a Node environment and the version type you're testing for. And right now, it's failing because in my tests, I'm using minus instead of plus. But if I do this, save it, whoops. Travis should automatically detect that I made a change to my GitHub and I push it, and it's going to automatically build and see if my test will pass. And sometimes it takes a while. But you can see it's compiling the code right now. Still running. No. Something went wrong. Maybe I can run it again, but it should pass the build. Right now you can see that the build is failing right now with that red button. I'm hoping it passes. Okay, well, something is not working, but it was working before, and you can see the build history here. But if it does pass, you would get this green label right here. And usually it would say, like, when passing, whatever your test spec is. So there you go. That's continuous integration.